Good morning, good afternoon, everyone, and welcome to this lecture. So, we are starting with Newton laws of motion, and with this topic, I think things will move a lot swiftly. Newton laws of motion is what we are going to deal with. Now, as soon as we go into Newton laws of motion, the first thing that we are going to understand in this Newton laws of motion is what? Whenever you hear about Newton laws of motion, what is the first thing that comes to your mind? What is the first thing that comes to your mind when you think about Newton laws of motion? Yes, tell me. No, no idea. Okay, with Newton laws of motion, we are beginning with a topic which is known as dynamics. Up till now, we were in a topic which was called as kinematics, in which we were dealing with motion. We were only dealing with the motion and we had no clue or no idea, or we were not concerned about with the cause of motion. In this chapter, what we are going to deal with is dynamics. So we are going to deal with the cause of motion. What causes motion? What causes this motion? What is the cause of any motion? That is what we are going to deal with. So this chapter may not have more questions on what will be the velocity, what will be the initial velocity, what will be the final velocity. There could be some questions that could be made. What would be the displacement? All those things might not be of prime concern. What is going to be prime concern in this chapter is the cause of motion. And as soon as we move on to this cause of motion, we move on to the next heading. And the next heading, the next character is force. So basically, this chapter deals with force. Now, before going on to force, we can do a small thing because we might be needing it. We can introduce a term which is known as momentum, or I should better call it linear momentum. Linear momentum. Let us first get through this term which is known as momentum or linear momentum. You might have heard about this term, momentum or linear momentum. Any idea about this momentum or linear momentum? What do you mean by this momentum or linear momentum? Yes. See, it is a product of what? Mass and velocity of a particle. It is a product of mass and velocity. So if I write momentum, and momentum is normally written by the letter P, and it is a vector. So P vector becomes m times v vector. That becomes the definition of momentum. We will not go much into momentum in this chapter because we will be dealing with momentum in a different chapter known as the center of mass. There we will be dealing with momentum in a very detailed manner. Right now, momentum is just a product of mass with velocity. Some people also prefer to call it the amount of motion the body has. So we can also describe this as the amount of motion this body has. How much motion the body contains. Momentum is a measure of that amount of motion. And it's the product of mass with velocity. So if there is a massive thing, a train, an airplane, a ship, it's a massive thing. It has got very big mass, it may not have that big velocity. The velocity may be small, but once you multiply mass with velocity, the amount of motion that it has is huge. If a train is moving even very slowly, even to stop it, we need a large amount of force. We need a large force because the momentum is huge. Think about a body which has a very small mass but large velocity. A bullet on Earth, a bullet can cause a lot of damage. Why? The mass may be very small, but the velocity is very large. You might have heard about asteroids. There is a very small probability that one of those asteroids is going to hit. Even an asteroid of 1 kilometer long, 1 kilometer is very small. Even an asteroid of the size of 1 kilometer, if it hits Earth, Earth will be gone forever. All the life on Earth would be destroyed forever. Why? Because of the momentum it carries, it will move with a very high velocity, and when it strikes Earth with the gravitational pull of Earth, life on Earth, as we know, might be destroyed. This might be the reason of why dinosaurs suddenly disappeared. Anyways, momentum, amount of motion. What type of quantity is momentum? And you can see it is a vector quantity. Whenever we talk about vector, it must have two things. What are those two things?
Magnitude and direction.
It must have the magnitude, it must have direction. What is the magnitude of momentum? It is mass multiplied by velocity ka magnitude. And what is the direction of momentum? In which direction we will say a body has momentum? How will you find the direction of momentum of the body? What will be the direction of momentum of the body? So difficult. It will be same as what? Same as the direction of velocity, because it is mass multiplied by velocity. The only vector there is velocity. So the direction of momentum would be same as velocity. What about the SI unit? What about the SI unit of momentum?
kg per meter per second. kg meter per second.
Kg meter per second. Sometimes it is also known as Newton second, NS, Newton second. Once you know the unit, you may also tell me what is the dimension. What is the dimension of momentum?
LT minus 1.
MLT minus 1. Momentum, the amount of motion that a body contains. Okay. Now, once we are done with this, we must understand that in this chapter also, we are going to treat bodies as particles. Even if it is a train, even if it is a bus, or a boy, or a bike, or block, we are going to treat them as particles. We are not going to think about their lengths and breadths and heights, because that doesn't matter. Right now, we are into a motion which is known as translational motion. I told you about translational and rotational motion. Yes or no? So right now we are dealing with translational motion, and once we are in translational motion, we can treat all bodies as point objects, right? So whenever I say the momentum of anything, momentum of a bus, we are taking bus as a point object. We are taking train as a point object, or for that matter, anything, a car, a truck, we're taking them as points. We draw the diagram, we draw them as points, because their length and dimensions don't matter. They are going to matter in a different chapter. That chapter is going to come after 2 more chapters. Now, as soon as we think about momentum, amount of motion, we can also think about one more term that comes, which is known as inertia. Inertia. Have you heard about this term inertia? What do you mean by inertia of any body? What do you mean by inertia of any body? Inertia. Anyone?
Change in state of rest or motion.
Change in state of rest or motion is known as inertia. Not exactly correct.
Sudden change.
Sudden change. Property of a body. By virtue of which what? It resists any change in its state of rest or motion is known as inertia. Every body has inertia. Every body has inertia. Every body has this property by which it tries to oppose any change in its state of rest. If the body is at rest, it wants to remain at rest. If the body is moving with a uniform velocity, it wants to keep on moving with the same uniform velocity. It does not want to change. That property is known as
Yeah.
inertia. When I say there is motion, I must add translational motion. Translational motion, that would be more appropriate, because after 2 or 3 chapters we may again encounter inertia of a different kind, though it does the same thing, but it does it in a different type of motion. Okay, now you must remember that inertia is not a physical property. Inertia in itself is not a physical property that can be measured. So it's not a physical property. It cannot be measured. It is not a physical property. It cannot be measured. But then we know that if someone has more mass, it will require more force to start the motion. If a body is heavy, it requires a lot of effort to move it. So we can understand that inertia of any body depends on its mass. Do we understand this? Inertia on its own has got no physical sense, but we have found out that this depends on its mass. Inertia in itself does not have any physical significance. It has no unit, no dimension. What is the dimension of inertia? Nothing. What is the unit of inertia? Nothing. But yeah, you can measure the inertia of a body, or inertia of the body depends on its mass. Now, as soon as we understand the word inertia, and this is very closely related to what we are going to deal next, and that is Newton's what? First law of motion. So it is good if you can discuss this before going much into inertia. What is Newton's first law of motion? Everyone knows this, right? What is Newton's first law of motion or law of inertia?
Of inertia.
Yes. So what is that Newton's first law? Everyone knows this, yes or no? Everyone knows this, yes or no? What is Newton's first law of motion or law of inertia? A body will continue in its state of rest or state of motion unless it is acted upon by some external force. A body at rest remains at rest. A body in motion continues to move in that uniform motion unless disturbed by any force. This property is known as inertia, and Newton's first law of motion is also known as law of inertia because it defines the inertia of the body. Do we understand this? Everyone knows this? If a body is at rest, it will remain at rest. If the body is moving with uniform velocity, it will continue its motion with uniform velocity unless disturbed by any force. Law, or this property is known as inertia, and this law is known as law of inertia. Then if you want, you can understand this inertia. This inertia can be of 2 or 3 types. This is just for your knowledge. We can think of this inertia as 3 types. The first type of inertia is inertia of rest, if you want to call it that way. What does that mean? If a body is at rest, it will remain at rest. This property can be called as inertia of rest. Do we understand this? You have seen many examples of inertia of rest, right? If I am in a bus and the bus is at rest, suddenly the bus starts to move, I will experience a jerk. Why will I experience a jerk? Because the upper part of my body, which is not in contact with the bus, wants to remain at rest, but the lower part of my body, which is in contact with the bus, will start to move. I will not start to move, therefore I will get a jerk. If you have a tree and you shake the tree, the fruits will fall down. It's because of inertia of rest. Do we understand this? If you have a qaleen, if you have a doormat and dust has deposited on doormat, you put that doormat, you hang it and you beat it, doormat will move, dust will fall. All these are examples of inertia of rest. I think you would have seen those examples in your 9th standard, yes or no? So I may not elaborate much on this. I hope you know this. If there is inertia of rest, then you can call the second inertia as inertia of motion. If a body is in motion, it will continue to remain in motion. It will not stop its motion unless something acts on it. This property is known as inertia of motion. If I'm in a bus, the bus suddenly stops, you will fall ahead. Yes, beta?
Show me.
Not able to understand what you're saying. Yes, beta? Okay, that is inertia of motion. If a body is in motion, it will continue its motion. Right? Then you can define the third type of inertia as.
Sir, show the Newton first law.
You have not written Newton's first law.
No, sir.
What were you doing till now? Write it. You don't know Newton's first law, beta. 9th standard, you must have read Newton's first law. Anyways, write it. Do it fast. So, Newton's first law defines inertia. Inertia is the property by which if a body is at rest, it will remain at rest. If a body is in motion, it will continue its uniform motion. Have you written this?
No, sir.
Yes or no? Shall we move ahead now? We have discussed the three types of inertia. I hope you understand them. You don't have to note them down. You just have to remember inertia of rest, a body at rest will want to remain at rest. Inertia in motion, the body is in motion, it will continue its motion. Inertia of direction, if someone wants to change your direction, you will resist change in direction. A car, when it curves suddenly, you will again lean in one direction because you don't want to change your direction of motion. The car changes, but you don't want to change the direction. Inertia of direction. Yeah, these are in 9 standard stuff. You must have seen this. No one is going to ask you the examples of inertia of rest and inertia of motion because we are done with it. Now, once we understand this inertia, the next thing that we should understand is we have seen Newton's first law. Unless an unbalanced force acts on it, right? So the next thing that we must understand is force. Everyone has noted down inertia?
No, sir.
Okay, I'll give you time, note it down. Let me know once you are done. Everybody has understood what is inertia of rest and inertia of motion?
Yes, sir.
Great. Please note it down then. Try to do it quickly if you can. Inertia of rest, inertia of motion, and inertia of direction. Shall we move ahead now? Girls have done, boys, I don't know what they are doing. They are lagging behind the girls. Boys, are we there?
Done, sir.
Oh, thank God, sir. We are done, sir. Finally, we are done. Okay. Inertia of rest, inertia of motion, and inertia of direction we have seen. Now, since we talked about force in Newton's first law of motion, so we must now concentrate ourselves on force. What do you mean by force? You must have heard in your ninth standard, force is a
Or pull is called force.
push or a pull. Yes, you can also define force as a push or a pull. You can write it as a point wise. It is a push or a pull. Now, instead of calling it as a push or a pull, because right now we are not in ninth standard and we are probably in your 11th standard. What is force?
Sir,
Yes, can't hear you. Yes, beta. I don't know what's wrong.
sir, it is the product of mass and acceleration.
It is the product of mass and acceleration. That is not how we define force, and that is not you should ever define force.
It is
Force
a
is not.
vector quantity.
Yes, beta.
It is a vector quantity.
It is a vector quantity. So basically, I am asking you, what is an apple, and you are telling me apple is a fruit. Telling me whether it's a fruit or a vegetable. I'm asking you what is an apple. You're telling me apple is a fruit. You're telling me, or probably you're telling me something else. Force is a push or a pull. It's not mass into acceleration. No, that is not a definition of a force. Nowhere in any book you will see force written as mass into acceleration. When it is written as mass into acceleration, it means something else. You see sun, you see earth, you see moon. Now earth and moon, any two bodies in the universe. This is one body, this is the other body. If they interact with each other, if they influence each other, that influence, that interaction between any two bodies is known as force. So that is a better definition of force. Force is an interaction between two bodies or between a body and the environment. So the very necessary condition for a force to exist is that there must be two things. The first thing will experience force. The second thing is the thing that exerts force. So there must be someone who exerts force and there must be someone who experiences force. Whenever two bodies are interacting with each other, interacting means they are influencing each other. That is a force. Right now, you are listening to my lecture. I am interacting with you. I am exerting a force on you. That is how you understand force. Force is an interaction between any two bodies. You can also call force as a push or a pull. Do we understand this? This is how you can write it point wise. If you want to write it paragraph wise, this is how you will write it in a paragraph. What is force? A force is a pull or a push. Force is a pull or a push which changes or tends to change. Sometimes it may not change, but it will try to change the state of rest or uniform motion or the direction of motion of any object. In chapters that are going to come, it is going to change the size or shape of the body as well. So that interaction, that push, that pull, which does any of these things is known as a force. Do we understand this? This is how you define force. You don't call force as mass into acceleration. No, 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 no. Never in your life you call it that way. Force is an interaction between two bodies. What can force do? Number one, it can change the magnitude of velocity or speed. Number two, it may change only the direction of velocity. Number three, it may change both. Number four, which is going to come probably in the last chapter of 11th, the size and shape of the body. This will come in the chapter known as elasticity, where we are going to change the size and shape of the body using force. Until then, we are only going to do 1, 2, and 3. Change the speed or magnitude of velocity, change the direction of velocity, or change both. What type of quantity is force? Force is definitely a vector quantity. And how do I write force? F vector. This is how I write force. It's a vector quantity. What are the SI units? kg,
meter per second square.
kg meter per second square. You can also call it Newton. What are the dimensions?
MLT minus 2.
Great. MLT minus 2. MLT minus 2. This is what we should understand by force. Now I've written this. Everyone? I'll give you 2 minutes to write it. Girls have already done this. Boys, as always, are lagging behind. I hope there will be a day when boys will say, sir, we are done. And girls will say, sir, wait. Will that day come? I don't think so. Boys by nature are lazy. Nature wise, they are lazy. Isn't it? Note it down, fatafat.
So we are done.
Well done. Now, as soon as we talk about forces, there are quite many different ways in which you can classify forces. There is one way in which you classify forces, whether the bodies are in contact or not. That is one way of classifying forces. Then there is one more way which will come in the next chapter, conservative and non-conservative forces, depending on how the work is done. But if we talk about how these forces exist, or what are the basic nature of this force, whatever force you see around yourself, whatever force you see wherever in the universe, with our present knowledge, it comes in any one of these categories. These categories are made on the basis of the nature, how these forces exist, or how these forces come into being, who causes these forces. There are 4 types of basic forces in nature. Yes. Now the ball passes on to you. What are the basic type of forces in nature? There are 4 types. And we are going to study all these 4 types. Huh? No one knows it?
Gravitational force.
The first one that we discovered was gravitational force. Gravitational force. Okay. Second one.
Frictional force.
Huh? Frictional force? Not a basic force of nature, beta. The second basic force in nature is electromagnetic force. Electromagnetic force. The second basic force of nature, electromagnetic force.
Weak
Then
nuclear
the
force.
third type of force is?
Weak nuclear force.
I will call strong nuclear force as the third type of force. Strong nuclear force. And then the fourth type of force is?
Weak nuclear force.
Weak nuclear force. Now, the strong nuclear and weak nuclear force is inside the nucleus. When nucleus breaks or two nuclei come together, or when some sort of decay happens, then this force comes into the being. These force will be discussed in your 12th standard. In your 11th standard, what two types of forces we are going to deal with are gravitational force and some part of electromagnetic force. Now, when we talk about electromagnetic force, it consists of electrostatic force as well as it consists of magnetic force. Electrostatic force means the force between two charges. Magnetic force means the force between two magnets. Do we understand this? Previously, we thought that electrostatic and magnetic forces are different, but then we discovered that they come from the same phenomena. Therefore, they are clubbed together and they are known as electromagnetic forces. Now, scientists are working on a theory in which we call it the unified theory, where they understand that all these things should come from one. They call it the unified theory or string theory or whatever. So until the time when they discover it and they prove it, we are going to understand forces of four types. Otherwise, maybe 50 years from now, when I won't be there and you would be in my place, you would probably be discussing the string theory rather than these four forces. Anyways, four types. Which is the strongest and which is the weakest? We are not going to go into much detail, but we just have to have an idea which is the strongest and which is the weakest among these forces. Obviously, the strongest is gravitational force. Yes or no? Obviously, it is strongest. Ooh, such big moon moves around Earth, gravitational force. Such big Earth moves around Sun, gravitational force. Sun moves around the center of the galaxy. Galaxy moves around each other. All gravitational force. So gravitational force has to be. What has happened here? This has gone. Screen sharing has gone. So gravitational force has to be the strongest force. No questions asked, no answer given. We agree on this? Yes or no? Gravitational force has to be the strongest force, and indeed, gravitational force is the weakest force. It is the weakest. And did I miss something? It is not the strongest, it is the weakest of all the forces. How it can be? Such big sun moves around, Earth moves around sun because of gravitational. How this could be weakest? This is the weakest force. Even electromagnetic force is 10 raised to the power 4 times stronger than the gravitational force. Then which is the strongest? The strongest is the strong nuclear force. This is the strongest force among these. The only problem with this nuclear force, since it is nuclear, it is inside the nucleus, it acts on very small distances. But in those small distances, which is inside the nucleus, no one can beat these strong nuclear forces, not even gravity. Gravity goes hands down, it loses hands down. The strongest force is the strong nuclear force. We'll understand these forces in the 12th standard. The weakest is gravitation. Electromagnetic force lies somewhere in between. Now, what you must remember about gravitational force here, it is always attractive. Do we understand this? Gravitational force is always attractive and it does not depend on medium. Whatever medium, when gravitational force is the force of gravity, is the force that comes between two bodies of mass m1 and m2. We understand this? Yes or no? It is always attractive, remember that, and it does not depend on medium. What I am writing here is the differences between gravitational and electrostatic forces. Now, once we talk about electromagnetic or electrostatic force, basically I will talk about electrostatic force. Electrostatic force, it can be attractive and repulsive. Do we understand this? Like poles or like charges repel each other, unlike charges or unlike poles attract each other. Do we understand this? These electrostatic or electromagnetic forces depend on medium. They depend on medium. So these are the two types of forces. Now, since we have gone so far, I can also write the formula for gravitational force between two blocks. G m1 m2 by r square. Everyone knows this, yes or no? Where G is the universal gravitational forces, m1 and m2 are the masses, and r is the distance between the two bodies. Now, if I write the similar formula for electrostatic force, let me write it as Fe K Q1 Q2 by r square. This Q1 and Q2 are the charges and r is the distance between them. This constant K is not a universal constant because it depends on it is not a universal constant. This one is universal constant, universal gravitation constant. But that pink one is not universal constant. Why it is not universal constant? It depends on what? It depends on medium between the two bodies. Gravitational force between two blocks, two masses, two bodies, whether you keep them in water, whether you keep them in air, whether you keep them in space, whether you keep them in hydrogen, whether you keep them on sun, whether you keep them anywhere in the universe will remain same. Electrostatic forces will not. It depends on the medium. If you put them in water, electrostatic force will be different. If you put them in air, electrostatic force will be different. If you put them in hydrogen, electrostatic force will be different. Do you understand this? Or just go on above or at saying bye-bye. I'm going, don't worry about me. Okay. Now, the first category, gravitational force and electromagnetic forces are the 99.99. In fact, almost 100% of the forces that we see around us are either gravitational forces or electromagnetic forces, because nuclear forces exist inside the nucleus. Unless something big happens, you will never come to know about these nuclear forces. Something big like a nuclear explosion, like Hiroshima and Nagasaki, like an atom bomb. Unless until the atom bomb explodes, you don't understand these nuclear forces. And those things don't happen every day. So the forces that we see in day-to-day life are either gravitational forces or what? Huh? Or electromagnetic forces. Do we understand this? And these are the two forces that we are going to study. Now, the first of these forces is gravitational force. So we'll write the heading gravitational force. We will not go into much detail about this, because you must understand that there is a chapter completely dedicated to gravitation. So we will be doing this gravitational force in that chapter. Right now, we just must be concerned about what we are going to use in this particular chapter based on this gravitational force. We know that if you have two blocks, two bodies of mass m1 and m2, separated by a distance of r, there exists gravitational force of attraction, and that gravitational force is g m1 m2 by r square. Now, in this chapter, we are not going to use the gravitational force like this. Between two masses, what is the force? We will discuss this in the chapter on gravitation. In this chapter, what we are going to discuss is the gravitational force of Earth. Because in this chapter, we are only going to do problems on Earth. The problem is in space, rocket, and all those satellites. We will be doing in the chapter on gravitation. Force between two planets, force between sun and the planet. We will be doing that in the chapter on gravitation. Right now, in this Newton laws of motion, this chapter, we're only going to deal with questions on Earth. So when we do questions on Earth, the only gravitational force will be gravity. And what is gravity? What is gravity? This is the gravitational force exerted by This is the gravitational force exerted by what? This is the gravitational force exerted by Earth on bodies like us, small bodies which are on the surface of Earth, or bodies which are very close to the surface of Earth. Now, this gravitational force, it varies with height, it varies with distance, everything else. But for our discussion, whenever we do any problem, we'll always take this gravitational force. For example, if there is a block of mass m kept on any floor, one force will always act on it, no matter what happens. And that would be the gravitational force. And how will you find out the value of this gravitational force? The value of this gravitational force for this body will be equal to mg. So this gravitational force that we are going to study in this particular chapter, the magnitude of that gravitational force will be always equal to m into g. What is m? What is g? What is m? What is g?
Mass into gravity. Mass into acceleration.
M is mass and g is acceleration due to gravity. This is also sometimes known as the weight of the body. Weight of the body is the force with which Earth pulls the body. So the magnitude of gravitational force will be mg, and what will be the direction of gravitational force taken as? Direction of gravitational force will be taken as vertically downwards. It is same as the direction of acceleration due to gravity. In the previous chapter, we have always taken the acceleration due to gravity as vertically downwards. Here also we will take acceleration due to gravity as vertically downwards. Do we understand this? Yes or no? So whenever you have any block, any mass kept anywhere, it might be kept on an inclined plane. Only one force will always act on this block, and that force would be gravitational force, and would be always acting downwards. It might be kept on a block, it might be hanging from something. One force which always acts on it is always gravitational force mg, and it has to be always drawn vertically downwards. Do we understand this? Now, this is the first type of force that will come, and that is always equal to m into g, nothing much to discuss there. Then there are other forces also which are going to come in this chapter. Any idea? What are the other forces that are going to come in this chapter?
Normal force, frictional force,
Normal force, frictional force,
tension force,
tension force. Now, what type? I mean, we have discussed there are four types of forces, but now you are telling me normal force is a force, friction force is a force, tension is a force. In which category does they lie? Or shall I make a different category for them? Make one more column and write all these forces there. This normal force, tension force, friction force. They must lie in one of these categories, right? Because I told you, basically there are only four types of forces. In which category does those forces lie? Whatever forces you see in the universe are either one of these, as far as the present knowledge goes. So in which category all this forces that you said lie? 1, 2, 3, 4. Where does it lie? 1 is gravitation, 2 is electromagnetic, 3 is strong nuclear, and 4th is weak nuclear. In which category do they come?
Force, sir.
Number 4, weak nuclear. They exist inside the nucleus. No, you so don't see tension existing inside the nucleus, right? Or friction existing inside the nucleus. So obviously not 4. Now 3 options are left. The success ratio is 33%.
Gravitational force.
Gravitational force, we have already discussed gravitational force. Because of gravity, that is also gone. So out of 2, 1 remains. The success ratio has now drastically improved to 50%. Gravitation is out, weak nuclear is out. Then, in which category do they lie? Only 2 options are left. Yes? They lie in the category of electromagnetic forces. Day-to-day life, we may see them in the form of tension of the string. You may see them in the form of frictional force. You may see them in the form of reaction force or normal reaction force. Do we understand this? So all these other forces, apart from gravity, that you see in your daily life, you don't see weak nuclear forces in your daily life. You don't see strong nuclear forces in your daily life. The only 2 forces that you see in your daily life, because you live on Earth, you see gravity, gravitational force. You see moon moving around Earth, you see gravitational force. You see apple falling from the tree, you see gravitational force. Apart from that, whatever you see fall into the second category of forces, which is known as electromagnetic forces. So now we move on to electromagnetic forces. And what is the first type of electromagnetic force that we are going to deal with? Obviously, it is not going to be electrostatic force, because that will come in the next year. Obviously, it is not magnetic force, that will again come in the next year. Then what is the next type of electromagnetic force? So we'll write the heading electromagnetic force. All these are electromagnetic forces. They come from the same father or same mother. All the rest of the forces that you see around you are some form of electromagnetic forces. And the first type of force that we are going to do here is known as which one? Huh? Say. It is known as the reaction force. Or this word reaction may confuse you. You can also call it contact force if you want to. The actual name is the reaction force. Reaction force or the contact force. Whenever 2 bodies are in contact, see, even if they are not in contact, they can exert forces on each other. But when they are in contact, they again exert forces on each other. Those forces are known as reaction forces or contact forces. Do we understand this? So we will deal with this reaction and contact force in the next class. I would suggest that did you get the sheet for Newton laws of motion? Did you get that sheet? Okay. So as we move along, in that sheet you will see topic and subtopic. Read what all topics have been done and do the questions from those topics. I will see you in the next class, and we will deal with this reaction force in the next class. Take care. Have a nice day. God bless you all.
Thank you, sir.